we should be live.
Live is exciting.
What am I doing here? No, let's do this. We don't want that. Yeah, that's what we want. I make the technology. Do what I want.
You bend it to your
I
will.
bend it to my will. Technology. Hey, check this out. So there's a Kickstarter. It ends on May 22nd. ExoCube. Have you heard about this?
No, what is
No?
it?
So what it is they've got a Kickstarter, and they're gonna sell you a really cool there you go, ball that shows you all of the cube sort of shows you all of the planet positions, all the nearby 25 potentially habitable exoplanets sort of in a space around us in 3 dimensions. And then the money for the Kickstarter goes to help find more planets, which is
That
pretty
is
cool.
exceedingly cool.
Yeah, yeah. And so they sent me a bunch of these little exocube things. You open it. Let's see. You pull out this part to open it. Ready? Here we go. Boop. There you go.
That's kind of cool.
And you can help build the Colossus telescope.
That
So there you go.
it's so sad.
Exoplanetcube.com.
We're now crowdsourcing colossal telescopes.
Mm-hmm.
This makes me so sad.
Aw. Hey, whatever it takes.
Yeah.
Whatever it takes for us to get a big telescope that will help us see other worlds.
And they come with cool looking rocks. So I've opened up the Kickstarter page,
Yeah.
and the different cubes each come with a different stone. So you can order one that's the Alpha collection, and like Captain B has a green jade, and Wolf 1061C is a different. It's like pick what kind of rock you want to get, and yeah. Is it wrong that I'm excited by some of the rocks? I'm like the kid who just wants the box.
Yeah. Yeah, a little like my daughter. She's really into Steven Universe, and they deal with gems in Steven Universe. And so it's pretty funny that she's like, anytime she hears anyone say lapis or lapis lazuli or
Right.
Peridot, that's her favorite character is Peridot. When Dex Luthor asks me when I sit down, well, the chair back there. See more swag here. Hold on. Let's. So this is fun. Yeah. Patreon.
That's awesome.
Yeah, that's my Patreon hoodie.
Did you get that when you went and visited them?
Yeah. I went and visited Patreon, and they had some hoodies kicking around, so we stole some.
Was that part of your great Los Angeles escape?
Yeah. They didn't steal them. They gave them to us. Yeah, it was super fun. What else is happening? Man, first sunny day in.
Oh my gosh, me too.
Since winter began, since fall began, it was so warm yesterday, and so we were out in it. It was just amazing, and I got a bit of a sunburn.
we actually didn't have like running hot water for 5 days because our basement was flooded deeper than the hot water heater's pilot light. So we had to pay someone to come out and raise our hot water heater because that was easier than dealing with the flooded basement, which we're also going to have to deal with.
Oh,
But
owning a home sucks.
I haven't had like everything dry, like me, the dog, for about a week. My hair is still wet.
I've got a garage full of windows that we have to put in the next couple of days. So I'm going to say hi to a bunch of people. Hey to Adam Synergy and Aaron C. and Arnold Post and Ben Harris 1982 and Borat Klankar and Brian Daddy and Brian Stab, Carolyn B., Colin Jones, Daniel McCool, David Joseph Wesley, Dex Luther. That's a cool name. Dusty Reichwin, Ilat Avron, Eric Knapp, Fleming Thunberg, Francisco Alves, Giselle Sabrin, James Haney, Jamie Bradley, John M42, John Seffield, Quodlibit, Larry Beckham, Nancy Graziano, Peter Quinn, Raza Siddiqui, Brandon Brazil, Ricard Evgen, S. Wolberg, Selin Atale, Sergio Botero, Steve Heistand, Stephen Alvey, Stir Fry Kitten, Susie Murph.
Please don't stir fry kittens.
Stir Fry Kitty. Tag Tang, Unisofree, and Zapfan. Hey, everybody. Welcome to this episode of Astronomy Cast. So if you have no idea what it is you have stumbled into, we're going to take a random amount of time to carry out the recording of the episode of Astronomy Cast. When that wraps up, we will stick around and answer your questions about space and or astronomy. Pull no punches. Ask the most complicated questions you can think of. Pamela can handle it.
Maybe.
I gotta stop saying that like long, slow.
It's your transition.
It really is. I need to kill it. I'm gonna get like a rubber band and I'll snap it when I do that big long and that will get me out of this place where I do that. All right, let's get on with this show. Have you got your Audacity ready to record?
Mm-hmm.
Say when.
I am winning. I pressed record.
Okay. I have also pressed record. And clearly there is audio sounds coming from my microphone into my recording device. Hello, Chad.
Hello, Chad. You just gave it a very skeptical look.
You ready?
Yeah.
Okay. Astronomy Cast, episode 449, Robots in Space. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. With me, as always, Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
I'm doing really well. I mentioned just before the show, the weather finally turned, and this horrible, horrible winter, endless wet spring has wrapped up, and now we're moving into the warm part, the May, the flowers, and the being outside and not wishing you were in Costa Rica. These days are here. And it feels great.
Yeah, we're still like soaking, flooding, all of that stuff here. But at least it stopped raining. We haven't dried out, but it stopped raining. I hope all of you out there who have homes near levees, who have homes near dams, who have homes in all of the different floodplains out there, have everything you care about, including yourselves, above the high water line. I know our basement is pretty flooded, but I that's all we have. It's not bad, and I hope no one else has anything worse than what we have.
Well, you've got such a huge house. You probably didn't need to store a lot of stuff down in your basement.
Well, I mean, there's always the stuff like the Christmas tree.
Yeah.
The base of the Christmas tree is now soaked.
Right.
It will live.
Okay. Once again, I want to thank everybody for coming on to the Patreon campaign, patreon.com/astronomycast. This is, of course, the way that we can fund this show. If you've donated in the past and now you want to get on board the Patreon train with us, we would really appreciate it. That goes directly to pay Susie's salary for doing all the production, Chad's salary for doing the editing. That's it. That's where the money comes from for them, so we really appreciate your help. And I want to thank a bunch of the $10 patrons this week. Gordon Dewis, Bart Flaherty, Tyrone Fong, Margot Robinson, Les Howard, Paul Disney, Tim Shue, Matt Woods, and David Troke. Thank you so much for joining us on this wonderful adventure exploring the universe. We really appreciate your help. All right, let's get on with the show. When you think of a robot, you're probably imagining some kind of human-shaped machine. And until now, the robotic spacecraft we've sent out into space to help us explore the solar system look nothing like that. But that vision of robots is coming back thanks to a few new robots in development by NASA and some other groups. I always like to bring this up, how science fiction in many ways inspired us to become the fans of space and astronomy that we are today, and at the same time science fiction ill prepared us for what this space exploration future would actually look like. Where's my Stargate? Where's my transporter? Where's my warp drive? Where's my artificial gravity? Where's my
C-3PO?
Where's my C-3PO?
I want a protocol droid right now. Yeah, it's one of these things where most of those things aren't allowed by physics as we know it, and C-3PO is just really hard to program.
The Hitchhiker's Guide to the Galaxy described a robot as your plastic pal that's fun to be with.
You know, I think we have some of those, just not very many. And Boston Dynamics is working on building them out of more like aluminum and plastic.
Yeah, well, in prep for this episode, we both watched a bunch of Boston Dynamic videos. And man, those robots, like on the one hand, it's terrifying. And on the other hand, it's kind of sad.
So they have some robots that are just sort of like, I'm just going to watch this video on repeat and giggle for the rest of the day. They have one called Sand Flea, which is designed to be able to jump just like a flea can. And so it has 4 little happy plastic high traction wheels. It's super lightweight and it rolls around. And when it gets to the point where it can't roll any further, it leans back on its hind legs and deploys what looks like it's probably a piston or a spring of some sort and propels itself up, over, around. It like jumps onto roofs. It's a little jumping cutie pie, basically.
But I love the episodes where some handler is kicking or pushing or shoving or stealing things from the robot and watching it struggle. It's amazing how we anthropomorphize these robots.
And what's fabulous is it's easy as a human being to take the pause of the robot doing what is essentially the robot version of recalculating that Siri gives me every time I take the wrong turn. That pause, while it sorts itself out, we take to be the robot going, well, but you stole my box.
Why'd you shove me?
Yeah, exactly. It looks exactly the same. Because the robot's not talking while it recalculates.
Well, we're not going to feel sad when those things are marching in the streets, rounding us up for the various robotic harvesting facilities. So just remember that time when you felt a little bit of sympathy for our robot overlords, who I won for. Welcome our future robot overlords. Yes. Harvest me last. All right, Pamela. But in a sort of chilling precursor of that robotic nightmare, there are some really cool robots being developed, humanoid robots being developed for space exploration.
And not only that, but they're developing them like one body part at a time, which is particularly humorous to me. So we're all fans around here of the Canada arm. I think that's safe to say.
Yes, we are.
Yes.
You know, we're doing a stamp for it.
Yes, yes. And not only that, but one of your upcoming bills has the Dextre robot on it as well. And so Chris Hadfield introduced that while he was in space. And these robot arms were the starting point for robots in space. They flew on all of the all of the space shuttles that flew for the last 20 years while we had a space shuttle. And now there's a Canada arm up on the International Space Station, and it is joined by a multi-armed friend, which they named Dextre with a French RE at the end. And the reason they started with arms is like, what's the only reason that we exist for cats? We have thumbs. And it turns out this combination of the elbow with its 1 degree of freedom, the wrist with its multiple degrees of freedom, and then all of these little dexterous fingers we have. It's that combination of mobility and degrees of freedom that make humans able to do useful things in space. So our useful robots start with that dexterous part.
Right. And right now, like, what can the robot arm, like the one that came with the space shuttle, what kinds of purposes, what would they use that for?
So the original Canada arm was used for everything from grabbing on to the Hubble Space Telescope to moving things into place while they were building the space station, to holding astronauts in place while they were working on things. So it was literally that hand up that sometimes you need when you're moving things around. It had the capacity to rotate things out on the hand end. It could bend to lift things out away from the space shuttle and then fold in to bring them into the cargo bay. And it's an extension, it's a crane, it's a rotation mechanism. All of these different position something exactly where you need it, kind of, I need a third arm. Well, Canada provided that third arm, and it just happened to be many meters long.
What method of operation did the Canadarm use? How did they control it?
It was literally a fly-by-wire. So it was not so much a robotic arm in the sense that a good robot is one that can do a series of complicated actions all by its lonesome. You say, build this Lego log house or Lincoln log house rather, and it builds it. Assemble this General Motors car, and it assembles it. The arm started out more like, okay, I have a bunch of joysticks. I'm an astronaut. I shall make the robot arm do things. I shall be its overlord.
It's like a backhoe, right?
It is.
I mean,
yeah.
I imagine like a person operating a backhoe or like some kind of excavator, and they're pulling the actuators back and forth, and hydraulics are making the big scoop function. So that's the kind of original level of robotics, and as you called it, the Canadarm. We're proud to donate that to the future of human space exploration. So let's talk about the Dextre then. The Dextre was sort of the next version of that new space station, needing a new robot arm.
And Dextre starts to look like what science fiction trained us to think a robot should look like. It's this little, and it's only little compared to the International Space Station. It's actually quite big. Its arms are 11 feet or 3.5 meters long. So it's quite big, except next to the International Space Station where it happens to live. So it is basically a central pillar, and it has two very foldable, bendable, twistable arms attached to it. And it is designed to do the difficult, dangerous outside work on the space station. There's a whole bunch of different things on the space station that just regularly need to be swapped out. We send new ones up on various SpaceX and Russian spacecraft, and somebody or a robot has to go outside, grab the new orbital replacement unit, go in, take the old one out, put the new one in. This is where two arms are useful. And this is what Dextre does. And we now have the ability with robots that they can just sort of climb around on the outside of the space station.
Right, and I think that's what's so interesting with Dextre. Unlike the Canadarm, which was really positioned on the space shuttle, it had a point that it could reach out and try to grapple things. Dextre crawls around
It's
the
awesome.
the outside of the International Space Station. Or it can be on the Canada arm, but it can also sort of be moved into different positions on the station to do work. And it's got multiple arms. It can hold things, grab things, give things to astronauts. It's a very handy robot buddy.
And they do stick it on the end of Canada Arm 2, which is the new arm on the International Space Station. So you have a multi-armed robot mounted on the end of a robot arm. It's robots all the way down.
Right. Now, is Dextre automated, or is it fly-by-wire? Is it also controlled by an astronaut?
It can do a lot of these things, not Dextre, go grab that off of the SpaceX capsule or go grab that off the Dragon capsule and install it on the Japanese module. No, it's not that smart, but it does have pre-programmed routines it can do. So you're not sitting there very carefully with a joystick swapping out components. It knows how to swap out components.
So this is the pathway that we're on to move to a more automated, more humanoid kind of robotic system. What's the other sort of next kind of robot that they're working with?
So Dextre lives on the outside of the space station, and Dextre is actively engaged in doing stuff that astronauts no longer have to do. On the inside, in a much more protected role, we have Robonaut. It's actually Robonaut 2, which is called R2, which is very Star Warsy.
R2, yeah, D2.
Yeah, not yeah. So Robonaut is the upper half of a humanoid robot. It has nothing below the waist. It's two arms, it's a head, and a torso. And Robonaut 2 has been up on the space station for a few years, and they've been working to figure out, can it do indoorsy things that the astronauts need done? There's not a whole lot of easy to find results, but it is a path that they're going down. And while there's a Robonaut 2 that's been up on the space station for a while, there are clones of the one that's on the ISS that are down here on Earth that are getting used for all sorts of different agility testing, performance testing, silliness. NASA does silly periodically. So there was around Super Bowl time a video that came out of one of the Earthbound Robonaut 2s doing all of the referees signals for a football game to show that Robonaut 2 had that level of dexterity. It's just kind of silly. But
I've seen versions of Robonaut attached to wheels.
Yes.
So it's this sort of centaur Robonaut where you've got the torso of Robonaut attached to rover wheels so it can roll around on the surface of some world. What's the long-term plan? I mean, having a humanoid-shaped robot in the space station kind of gets in the way. I mean, it's not going to be anywhere near as capable and as dexterous as a human being in the protected area of the space station. What is the purpose of this kind of exploration?
Well, there was recently a call I saw, a challenge for proposals to build a Robonaut 5 that would be capable of doing stuff on Mars. So long term, they're looking at low Earth orbit is probably the least hostile environment we deal with, because you can come home if things go bad. And where we really need the robots is to do the stuff that would imperil the astronauts' lives or that is simply a waste of their time. So this is where you want to be able to program your food machines, program your air filtration machines. And if you can have happy little robotic arms that go over and swap out your air filters, it's one fewer thing an astronaut has to do if you can get the robot to have the right aspect ratio. If we had a human-sized robot using a full-size vacuum cleaner to vacuum our house, I don't think any of us would be as thrilled as we are when our happy little Roombas get it right. Um, Roombas do the job instead of a human without getting in our way and interfering with our lives. If we can get robots on the ISS, if we can get Robonaut to be functional and take over tasks that are necessary and tedious and do it in a way that doesn't interfere with the astronauts, and get it so that maybe Robonaut 5 is going outside on Mars planting potatoes. It won't actually be planting potatoes, but going outside on Mars and servicing the solar panels and all the other kinds of things that are similar to what Dextre now does on the outside of the ISS. It's these dangerous and tedious tasks where we really need the robots.
And with Robonaut, you can also control it directly. A human being can wear kind of a virtual reality rig or wear a sort of fly-by-wire version of Robonaut and directly take control of the robot and move it around and have it look around and perform tasks as well. And getting into and out of, say, the Mars base is going to be a big pain that you're going to have to go and you're going to put on your spacesuit, or on the moon where you've got to bring in that awful lunar dust. You can imagine this future where you've got these robots that do a bunch of autonomous tasks, but then an astronaut can possess one and then do tasks that means that he or she doesn't have to put on their spacesuit.
And there's actually a fascinating book called Tin Men or Tin Man, I'm not sure which, that touches into the idea of basically downloading our brains into robots.
Now you went too far.
Yeah. So it's a book by Christopher Golden. It's called Tin Men. And the reason that things like this get kind of sketchy is the group that is putting the most money into robot development is DARPA, which fundamentally is looking to solve military problems. So when we look at those cute little robots that Boston Dynamics is doing, they have one that looks like a big old chest that you should be throwing tools in, except it's on 4 legs and it's covered in cameras, and it is trained to follow around its pack leader like a little dog, except it's big, and it will follow its leader for miles and miles and miles through crazy terrain. Because instead of putting stuff on the backs of Marines, DARPA is funding them to develop it to have this robot follow the Marines around carrying their gear.
And that makes me sort of think about Interstellar. Do you remember the robot that was in Interstellar, which was wonderful? It was one of my favorite parts, actually, of the whole movie, because that was a very flexible robot. It could didn't have to look humanoid exactly, but it could produce arms and finer tuned things, but it could also move quickly against over difficult terrain. It was a pretty interesting concept of what a future robotic companion could be. And that theme, back to science fiction, keeps coming up, that we've got this robotic companion that, let's be honest, we're going to have to go do the dangerous, dirty work.
Yes.
That is going to be more and more useful. Science fiction, I think, got this right.
And where it's getting interesting as well is robots, because they're not limited by joints and spinal cords and muscles and all of the things that at the end of the day limit our human abilities, because they can do a hybrid of wheels and legs and piston launchers. They're developing robots that have these hybrid mechanisms of motion that can go from being rolling rovers to jumping critters to climbing the sides of walls. And robots will be able to succeed in ways that mammals generally can't. And while some insects come close, insects don't pack the brain that these robots eventually will.
Right. So what's the long game then? What do you imagine, say we're 10, 20 years out, the first human missions are going to Mars. We're going to take some kind of robot companions with us. What do you think those sorts of missions are going to look like?
I think that it's going to be a suite of robots, and Japan really has done some interesting R&D on this, where they were thinking for a while of building a robotic moon base. And the idea is you have dexterous robots, robots that have finger, wrist kind of joints that are working on certain construction tasks. You have the rovery robots that are out patrolling the area, doing the checks on, do the solar panels need cleaned? Do we need to do this? Do we need they're the basic tests that you always have to do. And it's this combination of the wheels, of the hands, of all of these different kinds working in concert that will make things functional. There's a lot of research currently going into swarm and flock behavior, where they have people working to train groups of robots to play sports, where they have people training groups of robots to figure out how to do inventory management together, where they'll actually start stealing from each other's piles of supplies if one robot's working faster than another. All of these cooperative things that they're working on figuring out how to program into robots, that's going to define our ability to go to Mars with maybe humans and
Humans, yeah.
humans and a few tons of robots. And the robots are just going to be the ones out doing everything while the humans sit safely underground going, hey, we're chill. And we're in the same time zone as the robots. So if something goes wrong, we're working in real time.
I mean, what do you think the ratio will be? I mean, humans to robots, to robotic companions.
I really think that the robots at a certain point will begin to outnumber the humans and things like this, because you can do so many different things with this. And if you haven't gone and looked through the Boston Dynamics website, you really should. The Boston Dynamics folks are working to build specialized robots that can go spelunking into wet, closed areas pretty much autonomously. They're working on giant robots that will follow around their human leaders carrying large supplies. They have robots that will climb the sides of buildings. All of these different combinations are what we're going to need to safely build a base where we're not constantly endangering human lives by sending them outside to climb ladders.
Yeah, it's interesting to me, that idea that we're going to get a much better sense of what are human jobs and what are robot jobs. Even on Mars, robots are going to be stealing people's jobs.
It's true.
Yeah.
It's true.
Well, thank you so much, Pamela. We'll talk to you next week.
My pleasure.
Save. Sorry, the chat froze on me. I didn't even realize.
I'm trying to figure out why Noel asked if I'm a Ferengi. I'm totally not a Ferengi. I don't have a capitalist bone in my body. This is the problem.
I'm the Ferengi, yeah.
Yeah, it's true.
Team here. What was that? Episode 449. Wow.
Sergey wrote, we're sentient meat puppets. I love that turn of phrase.
We use that a lot on the Guide to Space. I like to use that term. There's a classic book or short story called is it just called Meat? I think. And the gist is that two aliens are arguing about whether they should talk to human beings, because it's creepy because they're made out of meat, that they're an intelligent species that's made out of meat. And the you can find, if you do a search for it, I think it's just called Meat. short story Meat. You're like, well, how do they talk? Well, with meat. They flap meat, and they blow noise through meat. Yeah, they're made of meat, and so I talk about how, when you compare the capabilities of, say, cameras to our meat cameras, it's a whole other, it's a whole other order of magnitude. How much better. It's a wonderful story. Go check it out.
It's by Terry Bison
Yep.
and is available for free in its entirety on his website.
Yeah, and it's called Made Out of Meat, and it's a wonderful story, and I really love it, and so I make those references a lot. All right, let's get on to some of your questions. We have Larry Beckham says we have bacon vocal cords.
I just read that one too.
Yeah. Let's get back to some of your questions. ML Robbins.
We're ugly bags of mostly water. Okay.
Well, that's from Star Trek. That's from the Next Generation. Yeah. ML Robinson 59. What type of AI would be involved for space robots?
I don't know where to start with that question. One that runs on a GPU.
The way AIs will be used for everything.
Yeah, I don't know how to specifically answer that one. I'm sorry. I'm going to punt.
One of the things that is very interesting these days is how these AI programs are developed and the kinds of problems that they're solving with AI. I saw this great tech demo for future video games, like how to make a video game character walk across various kinds of terrain. And they've taken real human beings, done motion capture on them, had them walk across, climb up ladders and jump onto boxes and slide down the side of terrain and just walk along. And then they've used that to train an AI to have a virtual version of a person walk across virtual terrain. And the quality of the animation of this is stunning. It's so good.
Yeah.
Like, you're absolutely going to see this as the future. And so how you get AI to learn how to operate out in space is the way you get AI to learn how to do literally anything, which is that you just show it enough examples of anything until it learns, and you have no idea how it knows what it knows, what rules it created, what software it's generated. AI is kind of terrifying on that front, which is that you can't debug it, right? It just...
Well, you have to give it different training data. I mean, this is where things can go terribly wrong, is if you give something bad training data.
Yeah, give it the wrong
and
goal.
And there's so many different ways to go about it. Neural nets are the one I'm most familiar with, and that's probably not how this is going to be done, where you just try a bazillion different examples, and the ones that most closely match you breed them. It's...
William Vanderbeek asks,
awesome.
Have you seen Westworld, Deus Ex Machina, and what are your thoughts on robots becoming self-aware?
I haven't seen Deus Ex Machina yet.
Or Ex Machina.
I know I need to. Yes, I know I need to. I know I need to.
Good.
So I have seen Westworld, and oh my God. If you haven't seen Westworld, it's very adult. It's very, very adult. Do not watch it with children in the room.
Yeah.
But it's captivating.
Yeah.
And
now, did you watch it week by week, or did you watch it on a binge?
I binged it. Yeah.
I've heard that a lot of people are saying that if you watch it on the binge, it holds together a lot better, because I watched it sort of more over time, but I kind of wish that I'd all watched it in one fell swoop.
Okay. Yeah, I binged it over about a week, maybe not even that long. I might have done it over a weekend. And the idea that you can have software that, by being able to hold on to if this then that, learning from watching things, where you're constantly taking in new feedback mechanisms, and that gets you to sentience. Yes, that has the potential to happen, where we can no longer tell the difference between a machine that's learning from its experience in the way human beings learn from their experience, except in the details of the memories.
Yeah. Ex Machina is terrific and a very chilling look at how an artificial intelligence, a very high level artificial intelligence, will interact with us. And I don't want to spoil anything, so you should really
Well,
watch it. I know it's on.
Blade Runner.
No, you have to see this movie. You
Okay.
clearly haven't. You don't understand. Until you've watched it, our conversation about this movie needs to end here.
Okay.
So watch it.
If,
It is it with matched with Her. Have you seen Her?
no.
No. Okay, so Her is the happy version, the what I think is like one of the most wonderful and realistic depictions of artificial intelligence and our interaction and the ethical issues that come up when we interact with essentially an artificial but intelligent creature, right? A being. It's wonderfully done. It's very heartwarming almost. It's a great movie. It's one of my favorite. Her is one of my favorite movies. Ex Machina is the flip side of that, and just really well done. That just gives you all kinds of things to think about afterwards. So
I clearly will be spending the weekend watching movies.
yeah, watch those two. Her and Ex Machina. Watch those two.
Okay. Watch Blade Runner if you haven't.
What? Are you literally insulting me and saying that I haven't seen Blade Runner? Oh my god. I've seen starships on fire off the, how does it go? Off the shoulder of Orion. Attack ships on fire off the shoulder of Orion, which, when you think about it, is kind of ridiculous.
Are you thinking of Starship Troopers or Blade Runner?
Blade Runner. Time to Die.
I'm totally not remembering that scene.
In the end, now I'm spoiling it. If you haven't seen Blade Runner, it's a movie about synthetic people. And
with a very young Harrison Ford, and it's where the phrase do robots dream of electronic sheep comes from.
And in the end, Rutger Hauer is the last synth, and he's gonna die, and he makes this sad speech about the things that he's done and been and seen, including watching some kind of interstellar battle in a solar system 1,000 light years away. So, yeah. All those moments will be lost like tears in the rain. Yeah. Paul Dizzy, have you seen all 4 versions of Blade Runner? No, I have not. I've only seen like 2.
Yeah, I only knew of 2. Wow.
Back to the thing with AI, though. What's interesting, there's an interview with Sergey Brin from Google recently, and he was surprised at how quickly AI was progressing. If you watch this interview with him, he's like, and I was kind of like, I had been out of it for a little bit, and I came back, and and he's head in charge of the part that's working on this kind of stuff, and I was a little surprised. I was a little shocked at how far along this has all come. We're in the age of AI now. And once again, future robot overlords, I will make a great pet. Arjun wants to know, do we have the same CPUs in space, or do we use different ones to handle radiation?
We have old CPUs in space is what we have. So the issue that we run into is we need to space harden technology and test it out, and then test it some more, and then test it a lot more before we can use it for anything related to human beings. So some of the smaller R&D focused experimental missions will have modern processors that are just very well shielded. Same processors, just differently shielded. With things like the ISS, they're running several processors behind because they had to have the R&D mission that tested it. They had to have the bigger mission that tested it. Then they needed to test it a little bit more, and then it got used with human beings.
It's amazing to think of the capabilities of, for example, the processor on board Cassini. It's been out there for, let me think, like 17 years. How long has Cassini been out there? And then, but it was already old technology when they developed it. And so to look at the quality of the pictures that are coming back from Cassini, that is like 25-year-old technology that's out there.
Yeah. So the start date that I'm seeing is 1997. So that's the kind of technology that we're looking at. Is like it launched October 15th, 1997. So several years prior to that. So we're basically looking at some sort of Pentium chip, probably.
Yeah. Tom asks, when Cassini enters Saturn's atmosphere, will any telescopes on Earth or in space be able to see it?
I don't know.
I thought my answer was like, no way.
So they won't be able to see Cassini, but I don't know if they'll be able to see a splidge that it leaves behind. Because if you think about it, a chunk of something diving into Jupiter periodically causes stuff to well up to the surface.
Like comic shoemaker leaving on something with the mass of millions of Cassinis.
Yeah. So I don't know if there's liable to be a flash. I don't know if there's liable to be a ripple in the atmosphere. And more to the point, I don't know if they're going in on the side that would be lit and easily observed from Earth.
I mean, when they've had impactors on the moon and stuff, those were visible. Like, remember the impactors that went into the moon? Those were visible from Earth-based telescopes. But that's a good question. But we can guarantee that it won't turn Saturn into a second star, right?
It will not. No.
Now, if it contained, say, 150 more times the mass of Saturn, maybe 200 times the mass of Saturn, then it might pull.
It's not made of degenerate neutrons. Right. It's really not.
Or the mass of, say, 200 Saturns. If it was towing along behind it 200 more Saturns, then it could ignite it as a star. There was a question there that I wanted to get to. Wody bet. Okay. Our first space explorers will be robotic probes. Possibly aliens would do the same. Given that our robots are not anthropomorphic, is there something that we could learn from examining them, and vice versa? What could we probably discern from examining alien robots? So I think it's a wonderful question. If the alien robots showed up on Earth, what could that tell us about the aliens themselves that built the robots?
Well, I hope that the aliens did like us and plastered a gold record or moral equivalent on the outside of their space probe and sent to us what we sent to them with the Voyager. Failing that, if there's no engravings, if there's no easily accessed information about them, and all we're trying to do is learn from the morphology of the probe, we're not going to learn anything. If we see that everything is base 11, we might presume maybe they have 11
interesting
fingery bits, but they could be antennas. You don't know. So at most, we're going to learn what math system they like. And even then, we write software that's in base 2, base 8, and base 10. So it's not a certainty.
Are the rovers, like, for example, if an alien grabbed one of our rovers and looked at it, would they see it as in base 2? I didn't even think of that, right? Like, the underlying way that it processes instructions would be base 2.
I don't know if they did it in base 2 or base 8.
Well, it's binary code, right? I mean, at the end of the day,
I
all computer instruction is binary code. And so a alien civilization who didn't really understand how to translate it from binary code into the higher level machine language
yeah.
would say, well, maybe they have two of everything. Maybe whatever it is, they clearly are interested in some kind of symmetry. Anyway, computer scientists, if you're listening to this, I'd love to hear your thoughts about it. I love the question, and it's a really fascinating thing to think about. I love this. You're like totally gummed up now thinking about this.
Well, it's also the how do you get at any of that information?
Well, you could, for example, intercept the stream as it's attempting to transmit back to Earth, and
Yeah.
you could see that the stream is ones and zeros. So I can imagine ways that you could start to get a sense of what's going on inside the machine.
Yeah. It would still be really hard to back figure out all of that stuff.
Yeah, no, absolutely. But if an alien probe landed on Earth, these are the kinds of things that we would be trying to do. We would be trying to understand what it is and how it works, and how we can. Is it a threat?
And ironically, the people with the best skills to do this are the people who spend their time reverse engineering technology so they can steal it.
Right.
So we'd be wanting to hire a whole bunch of hackers to reverse engineer and hack into. I mean, imagine doing pencil tests on alien anything. That would be awesome and wrong.
Trying to develop some sort of disassembler on alien code so that you can create a virus so that you can bring down their alien motherships. Yeah. On Independence Day. I love that. I love that question though. I think that's really fascinating. Just that how we create, or how we the tools that we create tell people about the thing that created it, and that people could then try and get some sense. Although now people are going to use that as a argument for intelligent design, and it's not. David Joseph Wells, he says, no disassemble. Oh, Johnny Five.
Quadlebec wrote, if aliens find that arm on arm on arm from the International Space Station, they'll be very confused about us and our anatomy. Yes.
Yes, they will. A few people mentioned a couple of robots, the bots from Elysium and the bots from Seven Eves. That's a great example. Seven Eves, I don't think we're spoiling too heavily, mentions quite a bit, uses robots to assist a tremendous amount of work that gets done to keep humanity alive in space. And crawling robots and little drilling robots and their swarm, as you mentioned, like swarm controlled, things like that.
Flocking behavior.
Dex Luther asks, you mentioned intercepting Curiosity's signal. Is it possible for other people to intercept the signal or tune into it themselves?
Only if you have a whole bunch of big radio dishes. I mean, that at the end of the day, you have to know when, you have to know what wavelength, and then you need a big enough dish. And these things generally require fairly big dishes. But yeah, you could totally intercept it.
Do they encrypt it?
I don't know. For the longest time, they didn't encrypt any of it, but I don't know nowadays. I'm going to say I don't know a lot today.
Okay, that's cool. It's very honest of you. I, on the other hand, will claim knowledge. I love that people are having an argument about a basic in the chat. Well, not really an argument. A pylon hate-a-thon, I guess, would be a way I would describe it. Which basic is so awful.
It is. Fortran is the white space usage in Fortran.
Did you hear that NASA has come up with a new competition to improve the Fortran operation speed of some of their old code. So it's tons of NASA is still running on Fortran, and it's not running quickly on modern processors. And so they put out this competition for various computer programmers to come up with algorithms that will help them speed it up. I think that's great. B. Nesheim asked, can we make robots that repair themselves?
Yeah. It's a thing.
I mean, not great.
Well, it depends on what they're fixing.
Yeah.
And ultimately, we're going to want to have robots that can 3D print things. And robot breaks arm, robot pulls off arm, 3D prints new arm, puts on arm.
Yeah.
That's what we want, is 3D printing of arms for everyone. An arm for you, an arm for you. We all have arms.
It's amazing how much of an impact 3D printing is going to have in space exploration. It's really interesting. When I first heard about it, NASA's planning on building a 3D printer for the space station. I'm like, that's ridiculous. Why? Just they need a wrench.
Replacement parts.
Send up a wrench. Well, that's exactly it. And that there are additional issues in being able to print this stuff in microgravity. But you can imagine future space stations or future moon bases where someone develops a new kind of technology, a new structure on Earth, and then they just beam the plans, and the nano assemblers spin them out, and now the folks on the moon base have little spinny toys that they can, and fidget cubes, right?
And what's awesome is we're already to the point where we have the technology to 3D print entire houses.
Mm-hmm.
They're tiny houses, but entire houses. And we're doing this here on Earth where, we have gravity, which is useful, but we also have like air and wind and rain. And so some things are easier in space, some things are harder in space, but we're making progress towards solving these problems. And we're going to be able to 3D print our habitats, 3D print our plates, 3D print. And suddenly what you're sending is not a container that has as carefully packed as you can knives, forks, plates, spoons, but rather has a glob of the stuff you need. And a book I'd recommend that does really good with 3D printers is Merle Lafferty's 7 Wakes. 6 Wakes. I gave it an extra wake. 6 Wakes. It is an excellent use of 3D printing. And for me to say anything more has spoilers.
All right. Well, at that point, I think we've reached the end of our hour. Thank you so much, Pamela, for once again participating in an episode of Astronomy Cast with me. Don't forget that if you want to hear the full show, you can actually get this now from the internet somewhere into your podcatching software, just the audio. But you don't have to show up live or watch YouTube after the fact. You can just have it download as a podcast, because that's the only civilized way to receive this information is by podcast. As I said, I like this show, but I wouldn't show up to watch it live. I would have it delivered to me as a podcast, and I understand. Astronomycast.com. Anyways, instructions how to get the raw feed from the Astronomy Cast website. I highly recommend it. Thanks again to all of our patrons. We really appreciate it. Thanks as always to the WSH crew. These are the folks who organize the online chat that's going on here, and they are the producers of the weekly Space Hangout. And one final big congratulations to our good buddy Morgan Renberg, Dr.
Yes.
Morgan Renberg, who battled for his doctorate. He defended his doctorate with his life yesterday.
And today's his birthday.
And today is his birthday, and he came through victorious, 1 year older, wiser.
And PhD bound.
Doctorate in hand. So congratulations, Morgan. Take a second, go to Morgan_Renberg, REHN, on Twitter. Send him a congratulations. Let him know that we're so glad that he got his doctorate. And you can join the hallowed crew who is now called the Doctor. All right, thanks everyone. We'll see you all next week. Wait, keep waving. I gotta find the stop button. There we go.